Hello guys, welcome to eMath Edge. My name is David Akwashki and I'm here to help you master mathematics and give you the edge you need to succeed in your exams. Here at eMath Edge, I will practically be solving mathematics past question for senior school examinations, where I will be breaking down the whole process into simple, easy to understand steps. I actually understand that preparing for math exams can really be hectic, but believe me, understanding how to approach these questions, most especially the essay part, will ease you a whole lot of stress. And that is what this platform is designed to do for you. Each video is designed to boost your confidence and make math exam feel less like a mystery, but more like a basic thing you can conquer. So with that being said, let's get started. Now, there is a GCE question for 2020, and the question said, find the inverse of the matrix A, which have the elements 4, 3, 7, and 6. And verify your answer by showing that the product of matrix A and the inverse of matrix A is equal to an identity matrix. This is I, which stands for identity matrix. So you are to first find the inverse of this matrix A, after which you are to confirm or verify if the product of the matrix A with the inverse which you obtain will give you an identity matrix. So first and first, let's go ahead and find the inverse of the matrix A. We have matrix A to be equal to, we have 4, 3, 7, and 6. Therefore, the inverse of matrix A, which is mostly represented by A to the power of -1, is going to be 1 all over the determinant of that matrix A multiplied by the adjoint of that matrix A. So this is the formula for obtaining the inverse of a matrix. First, you need to obtain the determinant, that is if it is not given. And secondly, you also need to obtain the adjoint of the matrix if it is not given. Then you substitute it into this formula to obtain the inverse of that matrix. So first and first, let's go ahead and obtain the determinant of the matrix A. To obtain the determinant of A, we are going to have it to be the absolute value of A. Now we know this is a 2 by 2 matrix, and for us to obtain the determinant for a 2 by 2 matrix, what we do is simple. Find the product of the elements in the major diagonal, subtract by the product of the elements in the other diagonal. So quickly, let's go ahead and do that. The product of the element in the major diagonal is 4 multiplied by 6 minus the product of the elements in the other diagonal, which have the elements 7 and 3, is going to be 7 multiplied by 3, such that if we simplify further, 4 times 6 is going to give us 24, right? Minus 7 multiplied by 3, which is going to give us 21. So 24 minus 21 is going to give us the value 3. So that's to say the determinant of this matrix A is 3. Since our target is to obtain the inverse of the matrix A, and we've obtained the determinants to be 3, the next thing to do is let's substitute the determinant into the formula of the inverse. Therefore, we are going to have the inverse of A to be equal to 1 all over. And what is the determinant? The determinant is given as 3 multiplied by the adjoint. Now, let's obtain the adjoint. For a 2 by 2 matrix, the simplest form or the simplest way to obtain the adjoint of a matrix is observe the elements in the major diagonal, which is 4 and 3. So what you will do simply is to swap this element in the major diagonal, which is going to give us 6 and 4, right? Instead of 4 and 6, we swap it. After then, introduce a negative sign to the other elements in the other diagonal. So it's going to be -3 and -7. So this is the simplest way to obtain the adjoint of a matrix, a 2 by 2 matrix to be precise. You swap the elements in the major diagonal, after which you introduce negative sign to both elements in the other diagonal. So this matrix now is the adjoint of the matrix A, which we have to be 4, 3, 7, and 6. So having obtained this, the next thing to do is to simplify further is you multiply the scalar value, which we have here to be 1 all over 3, multiply it by the adjoint of the matrix, which we have with the elements 6, -3, -7, and 4. So this now will take us to a scalar multiplication, right? Where we have a scalar number multiplying a matrix. And based on the principles of scalar multiplication, you use this scalar value to multiply each element in the matrix. So let's go ahead and do that, such that we are going to have now 1 all over 3 multiplied by 6. 1 all over 3 multiplied by 6. We can convert this to 6 all over 1, such that 1 multiplied by 6 is going to give us 6 all over 3 multiplied by 1 is going to give us 3. Such that if we simplify further, 6 divided by 3 is going to give us 2, right? Why? Because 3 into 6 is 2 times, and 3 into 3 is 1 times, which is the same thing as 2 all over 1, and is still 2. So that's to say 1 all over 3 multiplied by 6 is going to give us a single value, which is 2. We've succeeded in obtaining the elements in the first row and first column to be 2, right? So the next thing to do is to obtain the element in the first row and second column by multiplying the scalar value 1 all over 3 by the element we have in the first row, second column. So it's going to be 1 all over 3 multiplied by -3. We can take this to be 1 as well, such that we are going to have 1 multiplying -3 is going to give us -3 all over 3 multiplying 1 is going to give us 3, such that -3 divided by 3 is going to give us -1 or -1. So that's to say the value in the first row and second column is going to be -1. So now we are looking for elements in the second row, first column. So how do we do that? We multiply the scalar value by the elements in the second row, first column here, such that we are going to have 1 all over 3 multiplying, mind you, the element there is -7. So we are going to have it to be -7. So we take it to be -7 all over 1. So 1 multiplied by -7 is going to give us -7 all over 3 multiplied by 1 is going to give us 3. So the value we have for this element in the second row, first column is -7 all over 3, right? So the last one is the elements in the second row and second column. So let's go ahead and do that. We are going to have 1 all over 3 multiplying 4, which we can take to be 4 all over 1, such that 1 multiplied by 4, we are going to have 4. 3 multiplied by 1, we are going to have 3. So we cannot simplify this further. So we have our result to be 4 all over 3. 4 all over 3. So this is the inverse of matrix A. What did we do? We obtained the determinant, which is 3, after which we obtain the adjoint. As we substitute them into the formula, we obtain the matrix, which is having the elements 2, -1, -7 all over 3, and 4 all over 3. Mind you, that is not all. We are as well asked to find or to verify if the product of matrix A by the inverse of the matrix which we obtain will give us an identity matrix. So, to verify if the product of matrix A by the inverse of matrix A is equal to an identity matrix. So what we are going to do is simple. We multiply the A by the inverse, right? Which we just obtained. And what is matrix A? From the initial question, we can obtain a matrix A, which is 4, 3, 7, and 6. So we have it to be 4, 3, 7, and 6. Multiplying the inverse of the matrix A, which we obtain to be 2 minus 1 minus 7 all over 3 and 4 all over 3. So this gives us matrix multiplication, and we know the rules guiding matrix multiplication, which in summary, I will say first row multiplying first column to obtain the element in the first row, first column. First row multiplying second column to obtain the element in the first row, second column. Second row multiplying first column to obtain the element in the second row, first column. Second row multiplying second column to obtain the element in the second row and second column. So let's go ahead and do that quickly such that we are going to have, let's compute for the above, the element in the first row, first column, that is row 1, column 1, which is this. Remember, we said you are going to multiply the elements in the first row by the first column. So it is going to be 4 multiplied by 2 plus 3 multiplied by minus 7 all over 3, right? So we are going to have it to be 4 multiplied by 2 is going to be 8 plus, now this is a fraction multiplying 3, so which we can convert to 3 all over 1, such that we multiply the numerator and as well multiply the denominator. 3 multiplied by -7 is going to give us -21 all over 1 multiplied by 3 is going to give us 3, right? So to simplify this further, we have a negative sign and a positive sign here, which if you multiply negative by positive is going to give us negative, right? So that's to say we are going to have 8 minus 21 all over 3. So to simplify this further, we can as well take this to 8 all over 1 so that we can solve the fraction with a negative sign as the operation. So how do we do that? First, since the denominators are not the same, what you will do is obtain the LCM, lowest common multiple, which is 3, right? Such that 3 divided by 1, which is this denominator, is going to give us 3. And that 3 multiplied by 8 is going to give us 24. Mind you, we have a minus sign here. 3 divided by this denominator, which is 3, is going to give us 1. So that 1 multiplied by 21, which is this numerator, is going to give us 21, such that 24 minus 21 is going to give us 3 all over 3, which will finally give us 1. So that's to say the element in the first row, first column, is going to be 1. So to further obtain the element in the first row, second column, which is at this point, we are going to multiply the first row by the second column of the next matrix. So let's go ahead and do that. That is R1 column 2, right? It's going to be 4 multiplied by negative 1 plus 3 multiplied by 4 all over 3, right? 4 multiplied by negative 1 is going to give us negative 1 plus. Now let's deal with this fraction, which is 3 all over 1 multiplied by 4 all over 3, such that multiplying the numerator, we are going to have it to be 4 multiplied by 3, which is going to give us 12, all over multiplying the denominators, which is 3 and 1, is going to give us 3. Mind you, 3 can divide 12, such that we are going to have 1 plus 12 divided by 3 is going to give us a single value 4, such that we can go ahead and add 1 plus 4 and we will have a single value 5. So this is the element in the first row, second column, right? So to further get the element in the second row, first column, R2, that's second row, column 1, is therefore going to be the product of 7 by 2 plus 6, which is 6 multiplied by minus 7 all over 3, right? Such that 7 divided or 7 multiplied by 2 is going to give us a single value 14 plus, let's deal with this fraction, which is 6 multiplied by minus or negative 7 all over 3, such that 6 multiplying negative 7 is going to give us negative 42 all over 1 multiplying 3 is going to give us 3. To simplify further, we have negative sign here and we have positive sign. So negative and positive is going to give us negative. So we have 14 subtracting 42 all over 3, right? Such that for us to solve this fraction, let's take this to 1. We have to obtain the LCM, which is 3, such that 3 divided by 1 is going to give us 3. Use that 3 to multiply the numerator, which is 14. 14 multiplied by 3 is going to give us 42 minus 3 divided by 3 is going to give us 1. Then use that 1 multiplied by 42, we are going to have 42, such that 42 minus 42 is going to be 0, divide by 3, which is equal to 0. So that's to say the element in the second row, first column, which is this point, is 0. Now to obtain the element in the second row, second column, which is R2, C2, is going to be 7 multiplying negative 1 plus 6 multiplying 4 all over 3, such that we are going to have 7 multiplied by negative 1 is going to give us negative 7 plus, let's go ahead and deal with this fraction, 6 multiplied by 4, which is going to be 24 all over 1 multiplied by 3, which is going to be 3, equal to -7 plus, now 24 divided by 3, 8, and -7 plus 8 is going to be 1. So 1 is the element in the second row and second column. Something is wrong in obtaining this R1 C2. So this one, 4 multiplying -1 is going to give us -4 and not -1. So let's quickly do away with that. Let's correct that quickly. So R1C2 is simply multiplying the element in the first row by the element in the second column, right? So it is going to be 4 multiplied by -1 plus 3 multiplied by 4 all over 3, right? Such that 4 multiplied by -1 is going to give us -4, plus, dealing with this fraction, which we can take to be 3 all over 1, 3 multiplied by 4 is going to give us 12. 1 multiplied by 3 is going to give us 3, such that we are going to have 4 plus 12 divided by 3 is 4. Mind you, this is -4, right? -4 plus 12 all over 3, which is going to give us +4, such that -4 plus 4 is going to give us 0. So that's to say the element in the first row, second column is as well 0. Therefore, we can see that the product of A and the inverse of A resulted to this matrix, which is 1, 0, 0, 1. Which in conclusion we can say that this matrix is an identity matrix. Why? Because we earlier defined identity matrix to be a matrix whereby all its diagonal elements are 1. So in conclusion, we can say that the product of A by the inverse of A is equal to an identity matrix. We've obtained the inverse of the matrix, and we've as well shown that the product of A and the inverse is an identity matrix. So with this, we've come to the end of this video. Stay tuned and engage for the next one. Also, remember the goal of this platform is to solve as many past questions as possible, just to help you overcome what I call a maths exam tension. So if you have any challenging question from this topic that you would like me to help you solve, kindly reach out to me via email or DM, or kindly drop them at the comment section and I'll be glad to assist. Thanks for watching and have a great day.